Floor is yours. Thank you guys for being here.
Appreciate the opportunity, everybody. Can you hear me all right? So we're going to change gears a little bit. Heard a lot about conductors and such today. We're going to talk about ignition. We're going to talk about sources of fire and different ways we mitigate with our different technologies and solutions. And we really focus this on wildfires based on the topic that we were asked to discuss. But if we want to talk more about upgrade scenarios and those types of things, we specialize in that as well. We're agnostic to the conductor world. We work with everybody. We often have worked with a number of the CTC projects down in Southern California, Edison, where we'll go in and do what we do, which is tower raising, tower modifications, whether we're doing it for wildfire mitigation or just general overall ground clearance, spot mitigation, those types of things. We get involved in all of those. We're going to discuss more of the system itself, the transmission system versus the actual, just one component of the conductor. Just going to highlight a little bit of, some of the problems we see today. When I say today, these have been going on for a very, very long time in our industry. Little background on myself, second generation lineman. I'm also a transmission structural engineer. I've been in the industry for 35 years. I've been listening to stories about the industry for a lot longer than that. I often think I've seen it all, and then the next day I'm surprised with what get thrown in front of me. But ultimately, when we talk about the industry and how we're trying to improve things, and again, I think it was one of the commissioners up here said, we've got systems in place, regulations in place, in the auto industry, in the housing industry, and we have those in our own industries as well, right? In the transmission industry, we've got 100% fall protection. We have fire retardant clothing. We have equipotential bonding and grounding, which is basically grounding the line so it's safe to work on it. Or we have specialized transmission procedures to do energized work. We have those. What we do at Ampjack is really try and develop a better way to do certain things that utilities strive to do, struggle to do. I worked at a utility for over 22 years. I have a pretty good understanding of the constraints and challenges that my friends here from the utilities face every day, right? Whether it's fire mitigation or right-of-way acquisition or maintenance or repairs or new customers. I got a pretty good understanding. I built a lot of power line. I designed a lot of power line, and we really do our best at Ampjack to develop solutions that help and mitigate these situations. So let's go back to wildfire mitigation for a minute. We talked, and I heard Vice President Fielder say contact with the wire, right? SAG is 100% a cause of that, right? Whether the low sag is causing trees to grow up into it and making contact, or we've got falling tree issues all the time, right-of-way maintenance, large fuel left in the right-of-way. And again, I'm not going to sit here and point fingers at anybody, because everybody in all the stakeholders in my world that I work in with, which is the utility world, are trying to do their job, whether it's the environmental groups, the utility groups, the maintenance groups, all of those. And they're all doing what they think is best. We just come in and try and help those groups and find solutions that overcome those challenges. So, the vegetation issue, can we do a better job right-of-way maintenance? Maybe, but sometimes we're not allowed to, right? So what are some of the mitigation ways we can avoid contact with either growing vegetation, falling vegetation, those types of things? Down power lines. With transmission, we often see a fire will go through and there'll be annealing of the conductor, there'll be damage to the insulators, there'll be damage to the structure. And on the next big wind event, we might see failures, right? We're going to talk a little bit about how we can remediate those problems. Animal bird contact, squirrels on transformers, huge issue all over in the cities, right? For us, we see, and we're working on projects right now down in Southern Cal and actually up in the Northeast, where we've got a solution, a product that allows us to change the configuration of the tower to allow for more clearance. So large birds of prey, osprey, eagles can rest, build nests, those types of things, and less effect to the transmission lines. We'll talk a little bit about that as well. So what we're best known for, Ampjack tower raising, is tower raising. And we'll often get asked why. Why do you do that, right? Why would we want to raise a tower, a transmission tower? All comes down to ground clearance, right? I've heard everybody talk about ground clearance in here. Comes down to NESC, which is North American Electrical Safety Codes, OSHA regulations, CSA codes up in Canada. Everybody has their own set of requirements to say, at my hot sag, I will not be closer to the ground, the road, the bridge, the house than this, right? And there's different, every utility puts a buffer on it. Every state has different regulations. So ultimately, there's a North American code, and then there's all of the additional buffers and safety distances that utilities will put in. So we sort of manage all of that, like as far as trying to help them become compliant. But ultimately, it comes down to the clearance from the bottom of the wire, well, the clearance from the wire as it gets too close to the ground or the roads and such. Where we came in, I was with the utility when I decided to leave and pull together a company that helped utilities develop products and services like this. Was we started off mitigating what we call spot clearance. So a utility would have a span that has got that's in a national forest, and they're not allowed to manage the right of way to their liking, or they've got not enough ground clearance on this one span because somebody built a road in there or something like that. So we would come in and we would develop a tower raising system, which is basically, and I'll show you a short video that how it works. It's very simple. It's a hydraulically based crane in a box. We attach into the tower, we separate the tower, we jack it up, we put new steel, we take our tools home, and there you go. You've got additional feet of clearance. And that request of additional feet of clearance comes from our clients. They'll say, we need this much additional clearance in this span or in this line, or we want to gain this much more capacity. And we look at those requests and we develop methods and tools to help them achieve that, right? We've done over 1,500 tower raises in North America over the last 10 years, perfect safety record. We're very proud of that, of course. When you design and develop a tool like this, a method, a procedure, it's about improving safety, whether it's for the public, for our own workers, for the environment, whatever it is. You have to be improving safety all the way along the way. It has to be number one in your focus. The next big thing we do tower raising for is somewhat like the reconductoring groups we're talking about, is getting a full line rating, right? So re-rate the line. So we often, like I said earlier, we'll come in ahead and raise structures. So when they complete their reconductoring with the new high temperature cables, they meet all of the requirements. Often there'll be 20, 30% of that line that still needs to be raised after the conductor gets changed out. So we come in ahead of time and do those raises for the utility, or we'll do upgrades to the structures to allow them to do that reconductoring or just refurbishment, right? And then lastly, wildfire prevention we've done, and this sort of goes back to spot mitigation. We've done hundreds of locations for utilities where we'll go in and often we don't really even get told why we're raising the tower. We just get told how much it needs to be raised, and we'll go in and do that. But most of the time it's pretty obvious. We're standing in a national forest and there's trees growing up below it. Okay, well, doesn't take a rocket scientist to understand that they've got an issue with the clearances to vegetation, and we're going to help them by raising those structures. Right. The other thing I heard earlier, and I 100% agree with it, and I'm not here to profess that I can quote you numbers, but is raising the height of the tower gets the line further away from the heat source. And I've rebuilt a lot of power line in this world that has been damaged by heat, wildfires and such, where base of the tower is melted, aluminum conductor is melted and burnt, insulators are hardened and broken, all those things happen, right? So getting your line up out of that heat by raising it 10, 15 feet, and we saw on one of the gentleman's slide where 15 feet can make a huge difference in reducing the heat. You know, that's where we come in and we help them raise those structures. One of the keen and coolest things that we do is 99% of our tower raises, we do energized. We're the only ones in the world to do it. So we want to talk about return on investment. We can have that conversation all day long, but not taking the line out of service to do those repairs or those upgrades is a significant, way to overcome some of the challenges. You can't get lines out of service. Nobody wants to have their power off. It's very difficult to achieve those outage requests. It takes a very long time. If the weather goes foul that day that you're supposed to get the line out of service, your project gets stopped and you don't get to do that work while the line is de-energized. You're waiting, you're wasting time, and men and equipment, those types of things. So really, at the end of the day, having the ability to do it energized is sort of a game-changing situation as well for utilities. It really makes planning and organizing, executing the work a lot easier. I do coming up. Actually, so yeah, right here, we can play this little video just to give you a sense on what we're talking about. So ultimately what you're seeing here is a hydraulic crane that we install into the tower, right? We separate the tower either by cutting it or pulling the splice locations. We'll raise the structure by 5 feet at a time. And we're doing this all while it's energized. And then what we can do, yeah, we'll just hold it right here. Thank you. And then what we do is install the new steel into that structure. And then if we need to go 10 feet or 15 or 20, we do it again. We just regrip. It's kind of like an inchworm or a building crane that you would see. So we do it 5 feet at a time. And the reason we do that is for safety, right? If you put a 10-foot hole into the tower, we don't have, our linemen are big guys, but they're not that big. So everything becomes heavier and everything becomes harder to reach. So it's always a balance between safety and economics. Same thing with wildfire mitigation, right? We're looking at here at this structure or at this span right here, and you see you got trees coming into the line. And I see this on a daily basis. This is just a regular occurrence all over North America, right? Now, when you raise a structure or both structures by 15 feet, you can significantly reduce the heat that the conductor is seeing, the insulators are seeing, and you significantly reduce, and somebody's going to ask me later how much. I can't tell you the numbers. I'll tell you that right now. But when a tree cannot reach the line when it falls, or it cannot contact the line when the wind is blowing, whether the conductor is blowing side to side or the tree is blowing side to side, I've seen, I'm in the industry, I qualified to work on 500 kV and below. I've seen trees very, very close to the line that do not arc or start fires. By getting us out of there is a huge preventative measure, right? It is a significant change and a reduction in your wildfire potential, plain and simple. The other things that we see often, and we're fortunate enough to, our clients get very, they love to challenge us, and we love those challenges, is we get calls like this. We've got an osprey nest in a tower. They keep building this monstrosity of a nest. Environmental groups won't let them clean the tower. It won't take the nest out of the tower while it's fledgling, right? While there's birds in the tower. So what can we do to alter this tower to mitigate this situation? Right. So one is the what we call phase-to-phase clearance. So we can actually, with another product that we'll talk about shortly here, we can actually increase that distance between the phases so that your big birds of prey can fly in there safely, so they can land on the structure and not cause a short circuit, which is going to cause a fire every time. Right. The other thing is what we see here in the industry, and it's an interesting one, is what we call the spray. So when a bird of prey takes off from its landing perch, it always excretes a large spray of scat. And so it gets on the insulators and it gets on the conductor, and it actually is long enough that it can short circuit. And we see it often. We call them phantom trips until we figure it out, because we don't know why it's tripping out the line, but it is. And then eventually we'll find where, oh, it's because we've got this bird nest, and this large bird is always on that structure. It's a great vantage point for them. They hunt from there. Their little ones are safe, right? So we'll figure out ways to help, increase the distance in there to allow for that bird to operate safely, right? Ultimately, it's not my decision on if the bird should stay or go. I'm just there to help the utility overcome a challenge, whether it's, get rid of the bird or make the tower more accommodating for it. We're working on a project right now where the tower on the left, I guess can't see my description, but the tower on my left, so I guess that would be your right, the short one, is an existing structure, right? You can see there's a limited amount of space between the wire and the tower itself. So these large birds of prey are causing a significant challenge down in California. They're short circuiting out. They're causing wildfires. When they fall to the ground and they're smoldering and burning, they'll start a fire, or they're shorting out the line, and it becomes a reliability issue. The option in the middle is come up with a brand new tower design, build a new tower, I've listened to everybody talk about how many years that process takes here, how expensive it can be, 10 to 12 years to build a new right-of-way to accommodate, a bird of prey. That's a pretty drastic measure to decide to build a new line. Now, if we need an upgrade, and we'll talk about that, then it's a different conversation. But what we've done with a new product called ExoGrid is we've patented a technology that allows us to take that existing structure, keep the 2/3 of it, approximately 2/3 of that structure, and rebuild the upper section by modifying the lower section to handle the new loads, the new structural loads and the foundation, and increase the window space so there's more room for the birds to operate inside there, or we can increase the voltage. So now we're talking line upgrades, right? So as I heard the conductor groups talk more and more about getting more capacity out of line. Again, I'm agnostic to which conductor you want to use, but ultimately there's most often work to be done on these structures. That's where we come in. We come up with ideas, solutions, tools, methods to help achieve those goals. Let's recap this, summarize sort of the Ampjack tower raising. Again, we do a lot of it for wildfire mitigation, to spot mitigation, where one span is a concern for a utility, where we'll go in and raise one or both structures. The reason we would raise both structures in that span is fairly simple math. If I take two structures and I raise one of them, the belly of my wire, the lowest sag, goes up by half the distance that I raised it. If I raise both structures, it goes up by the full distance I raised both. So in other words, if I go up 10 feet on one structure, I only gain 5 feet of additional clearance. If I go 10 feet on both structures, I gain full 10 feet on the span. Make sense? Pretty straightforward. So Ampjack tower raising is done for spot mitigation, whether it's ground clearance issues, vegetation clearance issues, capacity increases. The utility says, hey, we want to operate our conductor hotter, whether it's through a new conductor or not. But we've got 6 spans in our 100 spans that don't have enough ground clearance to operate hotter. We can't crank the ampacity up because it's already too close to the ground. We'll come in and raise those 6 spans, right? So really quick way to get your return on investment, get your upgrade done quickly and without having to take the line out of service or buying new conductor, right? And I'm certainly not downplaying the requirement for new conductor. We do multiple projects where they're done in tandem. The ExoGrid, and I would ask it, and I was trying to focus this on wildfire, and I didn't want it to be a sales pitch, but everybody's been talking about technologies to find upgrade solutions. The ExoGrid is really designed to replace, and I'll put that in quotes, the need to build new transmission line everywhere. What this industry and what all of us as consumers and officials, I think, tend to forget is the value of our existing infrastructure, right? One of the gentlemen came and talked about the national highway system, right? And the value that is there is existing. Well, I've sat here and I've been listening to this and I've been challenged by this for 35 years now in the industry. Trying to build a new transmission line is not a simple proposition anymore. It's getting harder and harder to do. If you can take an existing transmission line and add a circuit on top or below, so by raising it, we can add a circuit below, or by adding an ExoGrid skeleton that increases the foundation strength, the tower strength, and supports the new circuit on top, so we can string a new high temperature cable. What you've done is you've reused your existing infrastructure. You've reduced your permitting times because you're not asking for a new right of way. You might be raising the height of the tower, right? But and there's allowances within the BLM for that. There's allowances for a percentage of increase of height and width and all those things. It's not just a yes or no. Now, by having the ability to put your new line on the existing structure at the same span, you're not disturbing any more area. You're not digging up more foundation areas, those types of things. So you can, in theory, and we're just in the process of this, so ask me in a year from now and I'll tell you definitively, does it significantly reduce the questioning around permitting? And so far, yes. There's even legislation that I've been warned about or told about that in the BLM group, in the Bureau of Land Management, if you're doing upgrades that are consist of maintenance style work, there's significantly less permitting, and that's about as political as I'd like to get. But ultimately, the idea with the ExoGrid is to reuse the existing infrastructure to add circuit, double capacity, triple capacity, whether you combine it with high temperature cables or not. That's up to the utility to make those types of decisions. They just come to us and say, we need this kind of strength capacity, and we come up with the ways and the methods and tools to do that. Right? And that's what our expertise is.
Well, thank you. Any questions from commissioners? Commissioner Bukacek.
I'm in a bit of awe by this tower raising, and I was wondering if we could see the video again now that I know what I'm looking at. Or I could look at it later too.
No, well, you know what? So yeah, I would love to show you on my, like, that didn't work very well. I'm not really sure why. It's supposed to, but try it again. But I would love to take 5 minutes of your
It's
time
pretty, yeah.
and show you some great videos from our clients.
That would be great.
That really, like, Southern Cal Edison is a great client of ours, and they're really going through a tough time right now with what's going on. All of the utilities in Florida and California are, and we do a lot of work with them, and they've been a very supportive client for over 7 or 8 years now, where we've raised hundreds of towers for them for spot mitigation, wildfire, or capacity increases, or helping them put high temperature cable on the line. So we've got some great videos from them. It's always better to show somebody a video that when somebody else is talking about you versus when I'm talking about me. So I would love to show you that.
But I want to hear your subtle Scottish brogue.
You have a user in the audience. Yes, Bonneville Power. We just finished 40 plus raises for them. Yeah, 500 or 345. I don't know. It's hard to keep track now. We've done a lot. So, but yeah, it's big voltage. And so if we're gonna dance around some of the regulation stuff, and I'd love to have this conversation. We talk about implementing new regulations, safer things to improve the systems and all that. And I put my example as well. We have 100% fall protection. We have equipotential bonding and grounding, which keeps our people safe. We have fire retardant clothing. What we've done here with Ampjack is we've eliminated what we call suspended loads. We don't have a tower hanging over people's heads anymore. Right? So the way we used to do this is we'd bring 2 large cranes in, and we would pick the tower with one crane, and we would use the other crane to insert the box, and we'd all be standing on the tower. And at the end of the day, we'd go like this, and we count all our fingers and make sure we had all 10 when we went home. Now we've changed that game, where we've developed a system where if we want to go up, we go up. If we want to go down, we go down. We have complete control of the tower at all times. It's a fully engineered process. We understand exactly what the entire system is putting onto the entire transmission system, the wire, the structure, the wind loads, all of those, because we max it out at a 25-mile-an-hour wind. We will not raise a tower and that's a big wind. We will not allow our crews to raise after that. So we understand the highest limit of the loads that we're going to be operating under. We design the system to that. We design the steel to meet the utilities requirements, specifications of a 500-year wind event or whatever it is, right? And we do the whole thing at a 4-to-1 safety factor. So we have a full understanding. It's a fully engineered process. It's very different than, I hope my crane's big enough today.
So I have a question for you, a couple, and then I want the crowd to be able to ask some questions of anyone here today, because I don't want to leave them out. Thank you for coming. Boy, and I'm excited you guys are here. One reason I am is fire prevention is going to be a tremendous issue, I think, in the next few months based on what's happening. So has Ampjack been used in fire prevention in the past? Tell me a little bit about that.
As I was saying earlier, we sometimes don't get told exactly why we're raising a tower, because utilities are a little secretive in the sense that it's sensitive, but sometimes our clients will come to us and say, we've got fire mitigation issues. We're sending you in to raise this tower or that tower to mitigate that risk. Okay. Or some of them will say, you're going in to raise this structure by 20 feet because there's a clearance violation, and we'll get there and we'll see the trees growing under the line, or we'll see the trees growing beside the line that aren't actually cut far enough back, and they have the ability to fall into the line when they break in a wind event. So we know, most often we always know it's fire mitigation, but we're not always told exactly that it is.
In Montana, we have the first recognized national park, Yellowstone, by Theodore Roosevelt. We have Glacier National Park. And I believe that we're going to see legislation that's going to raise the standards based on the billions of dollars that has been spent. I believe that there could be a situation where the distance on the conductor off the ground could be looked at where they'll raise those standards to say, hey, we've got to meet these new height standards. So you are going to be a great answer to that. But I want to make it clear that in some cases, we can bypass the permitting process. Permitting the structure can be very time consuming, can take years, millions of dollars of legal. You're able to come in and modify a structure that's already there. Do you think in most cases you can bypass the permitting process?
So, yes, sir. A lot of our clients, we get chosen to help do. So one of the gentlemen earlier talked about the system planning groups. They're the groups that work for utilities that are looking into the future, what capacity they may need, 10 years from now. And they're looking at projects, but they have this need right now. So we'll often get the call to say, hey, we need a right now solution, the Band-Aid kind of thing to get us 10 years. Right. And that's sort of how Ampjack, the tower raising portion of it started, was we need that right now solution to get us 10 years until we build a new line. And then over the last 10 years, what's happened is building new lines has become a lot more difficult. Right. So now they're starting to look at us as the long-term capacity growth, capacity increasing company. Right. So we're coming in and helping them gain. So Ampjack tower raising is different than ExoGrid, and I'll make it distinguish. Ampjack tower raising, in general, we can pull 20 to 30% out of the line by raising the existing line. And the reason we can do that, and that's real numbers, not line loss math. Those are real numbers based on what we call stranded power, stranded capacity. Why I talk about stranded capacity is, so when we designed transmission lines in the 40s, 50s, and 60s, and yes, we raised towers that old even today, we were very conservative and we did not have the computing power. So we limited the operating temperature of that cable to, let's call it, sorry, I'm doing the conversion in my head, or I'm a Canadian. So let's call it 150 degrees Fahrenheit, or even 120 degrees Fahrenheit operating temperature. We know now over the last 30 years, we can safely operate. When I say safely, I mean conductor will not fail at up to 212 degrees Fahrenheit, right? It operates on a long-term basis safely that way. Whether or not it makes a contact, that's a different conversation. But we cannot operate it to that temperature because we don't have the ground clearance, right? It's stranded. That capacity increase is there, but we can't use it unless we get the wire further from the ground. So what are the ways to do that? We have retensioning. So we'll actually go and unclip the wire and pull it a little bit tighter. That causes issues like vibration. As soon as you make something tighter, it vibrates more. It's like a guitar string. So it causes other issues. So one of the most mundane things you can do, and I've done all of these, right? This is what I do for a living. All of these different solutions we've done over the years. But one of the most mundane things you can do on a transmission line, not a distribution, I can tell you why, but is you raise the structures, because there's such a degree of freedom in the insulators because they're 5 to 12 feet long and there's 1,200 to 2,000 foot spans. So by raising one structure by 10 feet, if you think about it, the percent, you go up on a 200 foot structure, you go up 10 feet, which is 2%, is very little difference. The tension in the conductor changes almost imperceptibly, right? So it doesn't do anything significant to the existing line. Transmission or distribution is very different. The span lengths are too short. You can't raise structures that easy because you get this uplift problem. You get wire gets tight really fast. But in a transmission system, you have these long spans, and half the time they're going across flat open fields and such, right? Where you can modify the structure significantly to get more capacity out of that line.